Good day everyone, my name is Jorg Erika Arranguez. I am from IT2B, and today I will be presenting our project for Laboratory 3 titled School Management System Course Schedule Display Application. So this project was created as part of our laboratory activity that focuses on implementing and testing important concepts of object-oriented programming, or also known as the OOP. So this project is a simple application developed using the object-oriented programming approach in Java. The main purpose of this system is to display the course schedules of students, including the important information such as the course code, the course description, the instructor, the class type, the days, the time, and the assigned room. And aside from displaying the schedule, the main goal of this project is to demonstrate the proper implementation of the three fundamental concepts of object-oriented programming, which are the encapsulation, the inheritance, and the polymorphism. So these concepts helps organize the program into reusable, structured, and manageable components. So for the application overview, our application is designed to represent a simple school management schedule system, and the system stores and displays the schedule of different courses that the student takes during the semester. And each course contains several pieces of information such as the subject name, the instructor, the schedule, and the location of the class. And instead of writing one large block of code, we organize our program using object-oriented programming principles. This allows the program to be more organized, easier to maintain, and easier to expand in the future. In our design, we created multiple classes that represent real-world objects in a school system. The main class in our program is the course class. This class acts as the parent or the base class that contains the common information shared by all courses. And inside this class, we define several attributes such as the course code, the description, we also have the instructor, the type of class, days, time, and room. And these attributes store the information needed to describe each course schedule. So, to protect the data inside the class, we implemented the principle of encapsulation, and encapsulation means that the variable inside the class are declared as private, which prevents other parts of the program from directly modifying them, and by doing this, we ensure that the data is controlled and accessed only through the methods defined inside the class. This improves the security, organization, and reliability of the program. And another important concept used in our program is the inheritance. Inheritance allows one class to reuse the properties and behaviors of another class. And in our system, we created two child classes called the lecture course and the lab course. And both of these classes extends or inherit from the parent class called the course class. And because of inheritance, these child classes automatically receive all the attributes and the methods from the course class, such as what I have mentioned earlier, the course code, the instructor, the schedule, and the method for displaying the schedule. So this helps reduce the repetition in the code and makes the system easier to maintain. The third component of the OOP, or the third concept of the OOP, is the polymorphism. So our system implemented polymorphism, and what we mean by polymorphism, it allows a method to behave differently depending on the object that calls it. And in our program, both the lecture course class and the lab course class override the method called display schedule. And even though the method has the same name, each class displays a different heading when the schedule is shown. For example, in the lecture course class, it prints lecture schedule, while the lab course class prints the header as the laboratory schedule. So this demonstrates how the same method can perform different behaviors depending on the type of the object. And by combining these three fundamental concepts, which are the encapsulation, the inheritance, and the polymorphism, our program follows the core principles of object-oriented programming, and these concepts allow the system to be more structured, reusable, and easier to understand. And in the next part of this presentation, Mel will demonstrate the application by showing the code implementation and the output of the program, displaying the course schedule.
My name is Mel Jane Mae, Delima. So first we have the four classes which are the course.java, lecture course.java, lab course.java, and the main Java. So the first class is the course.java. So this will be our base class, meaning all the other classes will be based on this one. So I'll start by declaring the variables. So here I have the course code, description, instructor, type, days, time, and room. Now notice that all of them are set to private. This is what we call encapsulation. By making them private, we are protecting the data so nothing outside this class can directly change it. Now, I'll add the constructor down here. The constructor is what runs when we create a new course object. It takes all 7 values and assigns them to our private variables using this, that, and then down here I'm adding the getter methods, get course code, get description, and so on. So these are the only other classes can read our private variables. That's the whole point of encapsulation. Hide the data and control the access. And now, the display schedule method. This will print out all the course details. Now, this method is important because we're going to override it later in our subclasses, and that's going to be our polymorphism. Now let us proceed to the second class, which is the lecture course.java. So right here at the top, I'm writing extends course. This is inheritance. By writing extends, lecture course automatically gets all the fields and methods from course. I don't have to rewrite the course code, description, or any of those variables again because they are already inherited. Now, inside the constructor, I'm calling super. So this passes the values up to the course in constructor. And notice here that I'm hard coding lecture as the type. So whoever creates a lecture course object doesn't need to pass the type manually. It's automatically set. And then here's our display schedule with the override, like what I have mentioned kanina. This is polymorphism. Method is overriding. Where method is overriding, I'm telling Java that when display schedule is called on a lecture course object, use this version instead of the one in course, so it will print lecture first before showing all the details. Now we have the second class, which is the lab course, the Java. I mean the third one. Same idea as lecture course. It also extends course, also called super, but this time I'm hard coding the laboratory as the type. So ganina is ano man to sa lecture. So and the display schedule is also overridden, but it prints laboratory instead of lecture. So this is the clearest example of polymorphism in our project. Same method name, same way of calling it, but completely different output depending on which object you're using. Now lastly, we have the last file, which is the main, the Java. This is our driver class where everything actually runs. So here I'm creating the lecture course objects, which is the Soksai 11, literature 10, math 121, and so on. So each one gets 6 arguments: course code, description, instructors, days, time, and room. No need to pass the type because it's already handled inside lecture course. Then down here, I also created the lab course objects, the math 121 lab, ITC 121 lab, and the rest. Same structure, just lab course instead of lecture course. And the bottom, I'm calling display schedule on every single object. This is where polymorphism really shows. Java automatically figures out at runtime whether to call the lecture course version or the lab course version of the display schedule. Now, we are going to run this. And this will be, and here we go. You can see all the courses displaying properly. The lecture courses show the lecture header, and the lab courses show the laboratory header. That's our 3 OOP concepts: encapsulation, inheritance, and polymorphism, all working together in only one application. And that will be all for my part. Thank you.
In this project, several object-oriented programming principles were applied in developing the lecture course system. First is encapsulation. Encapsulation was used to protect the data within the classes. For example, in a course or lecture class, important fields such as course name, course code, and instructor were declared as private. This ensures that the data cannot be accessed or modified directly from outside the class, and it can only be controlled through getter and setter methods, which helps to maintain the data integrity. Second is inheritance. So inheritance was used to create a hierarchy or related classes. For instance, a subclass such as lecture course may extend a general course class. Through inheritance, the subclass automatically inherits common attributes and behavior from the parent class, reducing code repetition and improving code organization. So third is polymorphism. So this allowed the program to have a flexible behavior. So one example is overriding. Overriding the toString method so that the different types of courses can be displayed their own specific information. So this allows the same method to produce different outputs depending on the object being used. So during the development of the program, several challenges were encountered. So one of the common issues was resolving the mismatches and inheritance, specifically when debugging and working with the object from the parent and child objects. So these problems were fixed by checking methods and overriding, ensuring the correct data types were used. So another lesson we learned was the importance of consistently using the super constructor to properly initialize attributes inherited from the parent class. So for the future development of the system could include abstraction through interfaces to make the same more modular and flexible. So a graphical user interface or GUI could also be added using JavaFX to make the program more interactive and user-friendly. Additionally, the data persistence could be implemented using files or database so that the course information can be saved and accessed even the program closes. So in overall, this project strengthened our understanding of how OOP concepts work together in building real applications. So this project solidified our OOP skills for future applications. That would be all. Thank you for watching.